So we're starting section 5.1.2. This is the warm up. I believe there was a few questions in the assignment last night. So we have x to the negative first divided by x minus x to the negative first. This can appear pretty overwhelming to at first. Key difference between this and some of the examples from yesterday, this denominator has two terms. It's not all multiplication and division. So you can't just simplify the x to the negative first. That's not going to work for you. And because those of you who take the negative exponent and just move the location of that factor to the numerator and denominator and make the exponent positive, that's not going to work because, again, there's two terms down here, that's subtraction. So you can't just take this and move it up. So the best way to deal with this first is just address the negative exponents and rewrite them as positive ones. So this becomes 1 divided by x to the first right here in blue. X stays x, and then we have x to the negative first again, which is minus 1 divided by x to the negative first again. Using the concept we used in chapter 10, where we can get rid of all these little denominators, we're going to use that. So the least common multiple of the three little denominators, x, 1, and x here is x. And we're going to multiply by 1 in the form of x over x, where we're going to distribute this x to the numerator. So when I do that, it's going to simplify just to 1 for me right here. And then when I do it in the denominator, I have to distribute it to two terms. So then I'm going to end up with an x squared, and then one more time, I'm going to be left with a negative 1. So now I have 1 divided by x squared minus 1. This will not simplify, but it's a good idea to check, does the numerator and denominator after this multiplication simplify any further, or factor and then simplify? So x squared minus 1 is the difference of two squares. It will simplify, or will factor to x plus 1 times x minus 1, but that doesn't simplify any further. So both of these are acceptable, equivalent, simplified answers here. The next example here is 4 minus x to the negative fourth divided by 2 minus x to the negative second. Similar, but the difference is the numerator has two terms now, right? So we can't simplify anything the way it is at the moment, even the 2 and the 4, because of these extra terms, right? So it's not going to help. So again, rewrite everything as a positive exponent individually. So 4 stays the same, minus, and then x to the negative fourth becomes 1 over x to the fourth. 2 stays the same, minus x to the negative second becomes 1 over x squared. So we're again, least common multiple of all the denominators. So there's 4 of them. There's a 1 under 4, there's a 1 under 2. We have an x to the fourth and an x squared. So we need the least common multiple. So x squared is not the least because x to the fourth is not a multiple of x squared. But x to the fourth is a multiple of itself and a multiple of x squared. So that's our least common multiple. We're going to now multiply by 1 in form of x to the fourth over x to the fourth. And when we do our distribution here, we end up with x to the fourth minus this x to the fourth over this x to the fourth is going to simplify to 1. And then distribute in the denominator here. This x to the fourth times 2 is 2x to the fourth minus x to the fourth times x to the negative second is x squared. So this is where we're at. And at this point, again, you cannot simplify from numerator to denominator. This method we just used, what it did was it removed the negative exponents for us and the fractions. So this is where we're at. 4x to the fourth minus 1 divided by 2x to the fourth minus x. Now again, you want to look, does it simplify? Does it factor and simplify? So the numerator here is actually the difference of two perfect squares, just like this one. X squared minus 1 is the difference of two perfect squares. So this numerator will factor to the square root of the square root of 4x to the fourth, which is 2x squared, right? And the square root of 1, which is 1. But it's going to be 2x squared plus 1 times 2x squared minus 1. In the denominator, this is not the difference of two perfect squares, but you can factor an x squared out of both terms. So I'm going to factor that x squared out, and I'm left with 2x squared minus 1 here. I happen to have the same factors in the numerator and denominator here, so these will simplify to 1. And then we're left with 2x squared plus 1 divided by x squared here.